Okay, 3.1 solving system of equations. We're going to learn this lesson how to solve a system of equations with just two equations, and we're going to learn how to solve them three different ways. One, we're going to learn how to solve by graphing, which is up here. And then we're also going to learn how to solve it by elimination or substitution method. So let's first start with graphing. We have these two equations right here, number 5, and this is called a system of equations. Now, a system of equation is two or more equations with the same variable. To solve a system of equation with two variables, find the ordered pair that satisfies the equation. What they're saying is after you graph this, your answer, okay, is an x and y point. And that x and y point is where the two graphs intersect. Okay, so that's our answer. So let's first start with this first one. Y equals 0.5x plus 4. Really, that means 1/2 x plus 4. Okay, so you go to 4, graph it, up 1 over 2, up 1 over 2. And then down 1 over 2. Today is going to be really important to use graph paper. Let's look at this one. I'm going to divide this by 3. So y equals 4 over 3x minus 1. Now, I'm not going to connect the dots on this blue line because it might be easier because the graph's so small to see it. So down here at -1, up 4 over 3, and then up 4. Okay, so clearly you can see that my intersection is right there, okay? I want that point. That's my answer. So that answer is 6, 7. So my answer for this one is 6, 7. That's the intersection. And now that we saw that, I can connect these dots. The dot there, and connect those dots. And my intersection is 6, 7. So that's how you solve by graphing. Now, we're going to look at 3 things, and we have to memorize these, okay? We have an independent solution, we have a dependent solution, and we have an inconsistent solution. So independent solution would be like what we just did. It intersects, there's intersecting lines, and it's one solution. It intersects once. So that's my one solution, okay? To note this one, this has different slopes. Different slopes. Okay, if you get two lines that are parallel, if you get, we can go two. If you get two lines that are parallel, it's all the way over here. It's inconsistent. They're parallel lines. There's no solution. The reason why there's no solution is it never intersects. So the way to see if they're parallel lines is parallel lines have the same slope. And we know that because we learned that last chapter. Okay, and lastly, what if something is dependent, which is this middle one? That means it's going to be the same line and infinitely many solutions. So an example of that, you would have the same exact equation. You would graph like y equals x plus 2 and y equals x plus 2. So it'd be the same exact equation. Okay, so let's look at these first. Let's look at these 3, 10, 11, and 12. So I know for here it says to graph using a system of equations, but what's nice is now that we learned these little hints right here, a different slope for independent, a same slope for inconsistent, and the same equation for dependent, we technically don't have to graph in order to figure out this information. But what we have to do is every single time we're doing this, it has to be in slope-intercept form. Y equals mx plus b. So let's start off with number 10. Let's get the top one in slope-intercept form by subtracting the 4x to both sides. So you have y equals negative 4x plus 12. And then we're going to, the second equation, we're going to divide both sides by 3. Oh, let me change my color, sorry. So we have y equals, okay, 8 goes, I'm going to write the x first. So I could do negative 4x, negative 12 times, or sorry, negative 12 divided by 3 is 4. Negative 4x, and then that's plus 8 over 3. Okay, so I look at this one. I have, if you notice, I have the same slopes, negative 4 and negative 4. So I look up here, which one is the same slope? Parallel lines, and this parallel line is an inconsistent graph. You do not have to write consistent and independent. It's just inconsistent, independent, or dependent. Let's go to the next one. Number 11 is going to take a little bit more work. So first I'm going to move the negative 2x to both sides. So negative 3y equals 2x plus 9. I'm going to divide by negative 3. So y equals negative 2/3 x minus 3. Okay, and let's do now the bottom one. I'm going to subtract 4x to both sides, so that gets 6y is equal to negative 4x minus 18. I'm going to divide by 6. So I get y equals, reduce 4 and 6 to get you a negative 2/3. And 18 divided by 6 is a minus 3. So if I look at this equation and this equation, they're exactly the same. So this answer here is dependent. Okay, dependent. I don't know why that didn't come with me. Okay. All right, let's look at 12. Again, this one's going to require a little bit more work. I'm going to subtract 9 to both sides, so negative 2y minus, or sorry, equals negative 9x plus 11. I'm going to divide by negative 2. Y equals 9 over 2 x minus 11 over 2. Ugh, could you imagine graphing that? Yuck. Okay, next, sorry. I'm going to subtract the 5x to both sides. So 4y equals negative 5x plus 13. Divide 4 to both sides. Y equals negative 5/4 x plus 13 over 4. Who would want to graph that? Not me, even being a math major. I would not want to graph that. Okay, let's look at our slopes. Okay, clearly, I'm looking at these two, right? Clearly, we do not have the same equation. We don't have the same slopes. We actually have different slopes. So what is different slopes? This is independent. All right, let's move on. All right, substitution method. So substitution method literally means to replace, right? If you had a substitute teacher, they would replace me. So here's what we're going to do. What you can see is when you do substitution, you need to have, if you're going to do substitution, you must have one variable by itself. Now you're going to notice you're not going to do substitution often. You're going to kind of do elimination the most, but let's do substitution here. So I can see that I have y by itself. So I'm going to take 0.5x plus 4 and I'm going to substitute it into where y is into the other equation. So it'll look like this. 3 times, right? I'm going to substitute into this equation 3 times y, but my y is now 0.5x plus 4 equals 4x minus 3. So you're going to distribute the 3 to both terms. So you get 1.5x plus 12 equals 4x minus 3. I'm going to subtract the 1.5x to both sides. And at the same time, I'm going to add the 3 to both sides. So 15 equals 2.5x. Divide by 2.5. And x is 6. Okay. To find y, you're going to take that 6, x equals 6, and you're going to plug it back into one of these equations. It doesn't matter which equation. Usually I try to do the top one just to stay consistent. So y equals 0.5 x, but x is now 6 plus 4. So half of 6 is 3. 3 plus 4 is 7. So again, my answer here is a point. All your answers will be a point here. My answer is 6, 7. Now, here's my question. Does this look familiar to you? Right? Does this equation we just did, this system of equation, look familiar to you? And it should look very familiar, right? This is the very first one we did, but we solved it graphing. If I scroll all the way up here, we solved it graphing. And when we graphed it, it was 6, 7. That has to happen. So you can solve it by graphing to get 6, 7, or you can solve it using substitution and get 6, 7. Pretty cool, right? I think so. All right, let's keep going. So if we look at 4b, notice that none of the variables are by itself. Okay, so we want to get the variables by itself in order to do elimination. To do substitution. So what I would do is I see that my x is almost by itself if I add 7y to both sides. So I'm going to rewrite this equation as x equals 7y plus 11. I put the 7y on the other side. Now, by doing that, I'm now going to take 7y plus 11 and substitute it in for x. So when I rewrite that, 5, I'm rewriting this equation. 5 times x, which is 7y plus 11, plus 4y equals negative 23. I'm going to distribute. So 35y plus 55 plus 4y equals negative 23. Okay, I'm going to collect like terms and move the 55. So this gets me 39y. I'm going to subtract 55 from both sides. Equals negative 78. Divide by 39. And y equals, it should be negative 2. Okay, and then to find your x value, you can plug it into either equation. I'm going to plug it into this equation that I've circled in red. So x equals 7 times negative 2 plus 11. Negative 14 plus 11, negative 3. Now, you need to write it as a point because that's our answer. So negative 3, comma, negative 2. All right, let's keep going. Now we're going to do elimination method. So elimination method means we need to eliminate something. So notice I'm doing 4b again, but I'm going to do it in a different method. Okay, so I find the elimination method will be a little bit easier. And so let's take it from there. So eliminate. In order to eliminate something, you need to have a variable. Okay, a variable has the same coefficient in both equations. Okay, so it's going to be the same coefficient, but the coefficient needs to be negative. Okay, one needs to be negative, one needs to be positive, so it'll cancel out to make 0. So if we look here, I have a 1x and a 5x, and I have a negative 7y and a 4. So I need to get either the x's or the y's to be the same number, opposite sign. So what's going to be easiest for me is if I multiply the top row by negative 5. If I multiply it by negative 5, that'll get my x's to cancel out, because the bottom one is 5, so I want the top one to be negative 5. So negative 5x. Now here's a part that a lot of students forget. Not only does you distribute to the x, but it goes to the y, and it goes all the way over on the other side of the equal sign. So negative 5x plus 35y equals negative 55. And then the bottom is 5x plus 4y equals negative 23. Now we're going to treat this like an old-fashioned additions problem. Right? Remember when we would add like this and we would add down? So if we add down, the x's cancel out, which something must cancel out. We're left with 39y is equal to negative 78. And then when you divide by 39, y is equal to negative 2. And look how easy that is. We're done with like more than half the problem. Now, how do you find x? The same way you found x for all the other ones. You take it and you substitute it in. Does it matter which one you substitute it in? No. Again, like I said, I like to usually do the top to stay consistent. X minus 7 times negative 2 equals 11. X plus 14 equals 11. Subtract 14. X equals negative 3. And there's my answer, negative 3, negative 2. All right, let's keep going. Okay, let's look at 23. 23 is a little bit harder, right? Because now on 23, nothing really is going to cancel out easily for us, okay? So let's kind of talk about this. If we look at the A's, right, the easiest number to get for the A's to be the same would be 10, right? 5 and 2, what's in common? It's 10. 15 and 6, we could get a number in common, but I guess it would be 30, okay? Would be the lowest one, but 15 and 6 is sometimes hard to see if you don't know 30. So let's do the A's. I know the number in common is going to be 10. Okay, so the top one. 5 times, if I know this number is going to be 10, and I know 10 needs to be the coefficient, 5 times what gets me 10 is 2. And the bottom one, 2 times what gets me 10? 5. And here's what's also nice. The bottom A is already negative, so I don't have to multiply anything by a negative number. All right, let's keep going. So now I'm going to distribute 10A plus 30B equals negative 48. Now remember, it has to go to everything, right? Okay, the bottom, negative 10A minus 30B equals 140. Okay, let's keep going. All right, so we add down like a regular problem. Okay, the A's cancel out. The B's cancel out. So I'm left with 0 on the left side equals, what is that? It doesn't really matter. 92. Well, that's interesting, right? Does 0 equal 92? The answer should be no, it doesn't equal. This is a false statement. 0 does not equal 92. So what is my answer? No solution. If you were to graph this, it would be 2 parallel lines. Okay, so this is no solution. It's inconsistent. All right, let's keep going. Of course, we're going to have word problems, right? So we'll do this first word problem together. All right. So actually, let's do the modeling one first, and then we'll go back. So Geraldine has a $10 coupon and a 15% discount coupon for her favorite store. The store has a policy that only one coupon can be used per purchase. When is it best for Geraldine to use the $10 coupon? When is it best for her to use the 15% coupon? Okay, so you have to write two equations here. So let's write a $10, so that remember the $10 coupon would be, you would subtract from however much you spent. And then the 15% one, you would multiply, right? Okay, so let's do the $10 coupon. Y equals however much she spent minus $10. That would be your coupon one, right? Okay, so that's how much she would pay. Now, the 15% is a little tricky, right? You're taking 15% off, so how much would you pay? Okay, so let's do 100 minus 15, right? That gets you 85%. So if you take away 15%, you have to pay 85% of it, right? So y equals, we can't use a percent sign, so we're going to move it over to do a decimal, 0.85x. Remember, when is it best for her to use the coupon? So she's paying for it, okay? So these would be our two equations. And then you can use, I would do substitution method here, right? I would substitute this into the y. So it'd be 0.85x equals x minus 10. And I would solve from there. Okay, let's go back up to this word problem right here. All right, so modeling, write equations that represent the cost of printing digital images or photos from each lab. Okay, so what's nice is they've pretty much already created your equations for you in this box. So we have y equals 0.15 per photo, so that's telling you that's your rate, plus $2.70 for shipping. My other one is y is equal to 0.25 x per photo. So that's nice, okay, that they gave us that information already. Okay, so under what condition is the cost to print digital photos the same at both? So what does the same mean in math, right? The same means equal, okay? So what you need to do is you need to set them equal to each other. So 0.25x equals 0.15x plus 270. Subtract the 15x to both sides. So you have, 0.10x equals 270. And x is equal to 27. So what does that mean? 27 photos. Okay, so that's your answer for B. Okay. So C says, when is the best use of easy online digital photos and when is the best? Okay, so what you can do here is you could take 27 for C. For C, you take 27 and you plug it into both of these. So 0.15 times 27 plus 270. So what's going to end up happening? So let me do this one. 27 times. Okay, so this is 675. And then if we were to plug 27 to 0.25 times 27, is 675, right? Okay, so why is that? Well, it's because we set them equal to each other. Okay, so here's the thing that you have to realize is it's best or it's cheaper to do online. It's cheaper to do online when x is greater than 27. Okay, if x is less than 27, it's not as easy. And I think the easiest way to show you guys how to do this is on a calculator. So I want to show you this on a calculator in class next time. But this is the end of today's lesson.